Welcome all. Myself Shamla Devi, working as an assistant professor in the Department of Electronics and Communication Engineering at K.S.Rangasamy College of Technology. Today I am going to take about the concept on frequency modulation generation methods in analog communication systems. Frequency modulation, commonly known as FM, is a modulation technique in which frequency of the carrier signal is varied with respect to the instantaneous amplitude of the message signal. In frequency modulation, the amplitude of the carrier signal remains constant and only the frequency changes. So this is the main difference between frequency modulation and amplitude modulation. See, most noise affects the amplitude of a signal, but FM systems offer much better noise immunity when compared to AM systems, which is amplitude modulation systems. So because of this advantage, FM is widely used for high quality audio transmissions such as FM radio broadcasting and the television sound transmission systems. So this is the frequency modulation. So here first one is the modulating signal, which is the message signal, and then second one is the carrier waveform of high frequency signal, and then according to the amplitude of the signal, the frequency changes, which is frequency modulated signal here. And then in frequency modulation, the carrier frequency shifts above and below its original value, which depends on the variations in the message signal. And then we will see the FM parameters here. There are two important parameters that define the characteristics of an FM signal. The first parameter is the modulation index, and the second one is frequency deviation. So the modulation index is defined as the ratio of frequency deviation to the modulating frequency. The modulation index determines how much the carrier frequency varies with respect to the message signal, and it directly affects the bandwidth of the FM signal. And then frequency deviation represents the maximum shift of the carrier frequency from its unmodulated value. For example, when we take FM broadcasting, the frequency deviation is limited to plus or minus 75 kilohertz. So both these parameters play an important role in deciding the quality and also the bandwidth of an FM system. And then next one is we have based on the value of the modulation index. So the frequency modulation is classified into these two types, which is narrowband FM and the wideband FM. So in narrowband FM, the modulation index is less than 1, which is represented as beta is less than 1 here, which means the frequency deviation is very small. So as a result of this, a narrowband FM occupies less bandwidth and has a simpler transmitter and receiver design. So because of these advantages, these features, narrowband FM is commonly used in two-way radio communication and mobile communication systems. So why these are used in two-way radio communication and mobile communication system is their bandwidth efficiency is more important than the audio quality. So next one is wideband FM. So in wideband FM, the modulation index is greater than 1, which indicates a larger frequency deviation. So due to this large deviation, wideband FM requires a significantly higher bandwidth when compared to narrowband FM. So the major advantage of this wideband FM is its superior audio quality and excellent noise immunity. So because of these benefits, wideband FM is used in commercial FM radio broadcasting, where high fidelity sound transmissions and all required for those applications. So only we are using wideband FM here. So these are all the narrowband FM and wideband FM transmissions based on the modulation index value, which is beta here. So next one is the methods of FM generation. So first one is your direct method. So in the direct method of FM generation, the frequency of the carrier signal is directly varied based on the message signal. So this is usually achieved with the help of a VCO, which is voltage controlled oscillator. So in a VCO, the output frequency changes linearly with the input voltage. So when the message signal is applied to the VCO, the carrier frequency varies with respect to the message signal. so which results in frequency modulation. So the direct method is of simple in design and is widely used in modern FM transmitters and modern communication systems. So next one is indirect method of FM generation. So the indirect method of FM generation, also known as Armstrong method, generates frequency modulation in an indirect manner. So in this method, a narrowband FM signal is first produced using phase modulation techniques. So here phase modulation techniques play a major role. So this narrowband FM signal is then passed through a series of frequency multipliers to increase the frequency deviation and then convert it into wideband FM. So this indirect method provides excellent frequency stability and precise control over the modulation process, making it suitable for high performance and broadcast communication systems. So these are all the direct and indirect methods of FM generation. So, in the indirect method of FM generation, the process begins with the generation of a phase modulated signal, as I told before. So, this signal is then converted into narrowband FM. After that, frequency multiplier stages are used to increase both the carrier frequency and the frequency deviation. So by using multiple cascaded stages, the desired wideband FM signal is obtained. So this step-by-step process ensures stable and accurate frequency modulation here. So based on this indirect method of FM generation, when we follow this step-by-step process, we can ensure stable and accurate frequency modulation of a message signal. So next one is when we compare the direct and indirect methods. When comparing these methods of FM generation, the direct method is simpler and uses fewer components, making it easier to implement. However, it offers moderate frequency stability. On the other hand, the indirect method is more complex, but it provides excellent frequency stability and precise control over modulation index. So the choice between these direct and indirect methods depends on the application requirements and performance expectations. And then real world applications of direct FM is that direct FM generation is commonly used in applications like very high frequency FM broadcasting, mobile communication systems, digital frequency synthesizers, and satellite communication. So its simplicity and ease of implementation makes it suitable for modern and compact communication devices. So next one is real world applications of indirect FM method. It is used in early FM broadcasting systems, military communication system, precision instrumentation and legacy communication systems. So the high stability and accuracy produced by the indirect method makes it ideal for critical and long-term applications. So, frequency modulation on the whole is a highly efficient and reliable modulation technique that plays a vital role in modern communication systems. By varying the frequency of the carrier signal instead of its amplitude, FM modulation technique significantly reduces the effect of noise and interference by improving its signal quality. So, FM offers a better noise immunity when compared to AM systems. So these are all the questions based on the concept which I have explained before. So try to answer these questions. Modulation index and all here. So try to answer these questions. Commercial FM broadcasting frequency deviation as I told before. Thank you all.